Hi and welcome to the first of two videos regarding how to approach a problem-solving and modelling task. The first of these videos will outline what the problem-solving flowchart looks like and how to approach them, and the second deals with an example where we break it down further. But what about these PSMTs? Where have they come from? Well, with the upgrades to with the new senior secondary curriculum in Queensland, problem-solving and modelling tasks have been introduced into all four of the maths courses. If you're doing essential maths, the problem-solving and modelling tasks will make up roughly a quarter of your final mark. If you're doing one of the general courses like general maths, methods or specialist maths, then your PSMT actually makes up 20% of your exit mark. Now that's actually 40% of your internal mark, so it's a fairly significant proportion. And the PSMT is the only mark that is not reliant upon an exam. So it's particularly important for those people who don't handle the exam situations as well as they like. Regardless of whether you do or you don't, the PSMT is a good way of getting up to 20 marks stored aside against your name before you get onto the other assessments. So let's look at the problem-solving flowchart and how we apply that. This is a four-step process to solving problems, the first of which requires you to formulate a solution. So you'll be given an open-ended task and you'll be expected to actually formulate a mathematical response, and step one requires you to do that. Step two then gets you to solve that. Step three says let's look and evaluate and verify the reasonableness of your solution, and finally we communicate that in step four. So each aspect of this problem-solving flowchart has marks associated with it. So if you fail to actually do one of these steps, for instance you might have solved the problem but not evaluated or verified it, then you might get the marks for the solution, but you will miss out on any marks associated with the evaluate or verify. Similarly, if you evaluate but don't verify, you might get some marks for the evaluation, but again miss out on the verification marks. So it's important that as we go through and do solve the problem, that we adopt a systematic approach to make sure that all aspects of the problem-solving process are done. Let's have a look at them a bit more closely. So, to formulate, we've been given an open-ended problem that we've been asked to find some solution to. So we've got to define that problem mathematically, identify any assumptions that are associated with it, identify also variables and observations that we might see. We've got to outline too an initial plan for solving that problem. And once we've done that, we can actually move on to the solution. So to solve the problem, we will select and then apply an appropriate way to solve the problem. Now there's many possible approaches depending on the problem itself. We might be asked within the problem to actually develop a model to predict. So that would be, and we could do that by either refining an existing model or generating our own model, maybe from scratch or maybe using other models which are currently out and about there, and actually synthesizing 2 or 3 models together. If it's more a statistical based problem that we've been given, we might have to generate and test a hypothesis with either data we've been given or with data that we've collected ourselves. Or the problem might just require us to use a standard mathematical technique and adopt that and use it to actually solve our problem. We may need to revisit any assumptions and observations, and the second video will look specifically at this area as well as some of the others. Now your solutions can be found using any of these things. It could be algebraic, graphic, arithmetic or numeric methods to do it. Importantly, most of your problems will have the option of using technology, and you should adopt that if at all possible, both because it can be more efficient, quicker, but also because there are marks associated. Stage 3 sees us evaluate and verify. So now that we've got a solution, we've got to see that it's actually a reasonable one. So to do that, we've got to somehow go back and say, how can we show that our solution is reasonable? It might be just by substituting values back into a formula, okay? Or it might be by choosing an alternate way of solving the problem and looking to see that we get similar answers to the two of them. We should determine the strengths and limitations of the solution, and this is often tied up with any assumptions that we've made prior to it. So it's important to identify assumptions back up in step 1. Equally as important is that we're looking for refinements. So your first solution to the problem is not necessarily going to be your best. So we want to see any refinements that have been made. And typically there will be marks set aside for where you have refined them. So if you've just gone about and given one solution to the problem without revisiting it and making sure it's the best one, then basically you're going to miss out on some marks regarding the refinements. If you are making a model, you should actually check and demonstrate that this model provides a valid solution. So your model might be an equation which describes how the height of high jumpers has increased over time. What you could possibly do is actually substitute values in for the current day and see that it generates a height which is reasonable in terms of the maximum height that these high jumpers could do. So again, what you're doing is you're demonstrating that your model actually works. Importantly, problem solving and mathematical modelling is not a linear process, and it often involves you going back again and again to refine and improve your final solution. We want to see those steps. Now, obviously, we want to see the final model as the major one, but we should also be able to see this iterative process where things have been refined to a final solution. And finally, we want to be able to communicate that. And that should be done clearly and fully in a very systematic way where you've defined the problem, provided a solution, evaluated and verified it, and then you've communicated any conclusions. It should be done concisely using mathematical, statistical and everyday language. So what I mean by that is don't say in 100 words what you could say as well in 20. Be clear, be concise. Draw any conclusions you need to, discuss any key results, and restate any strengths and limitations of your models. Depending on the type of problem it is, you might also include further explanation, justification, or recommendations, and these should be framed in the context of the model itself. The context of the problem itself. Okay, so your response when we look at it should be written independent of the task sheet. That is, I should be able to remove the task sheet and read your solutions and see what the problem is, how you've gone about solving it, and that you've shown that it's a reasonable solution and verified it. Okay, also any assumptions, strengths or limitations that were associated with the solutions should be clearly stated. You must remain within the stipulated page length. In grade 10, in grade 12, this will be up to 10 pages. It may be shorter in years 10 and 11, but stay within the stipulated length. You can, however, use appendices, and these can be quite useful to show repeated calculations. I'll explain more of that in the second video. Your response should be unique. So that means that it should not be the same as any other person in your classes. You'll be asked to sign a document as you submit to show that this is your work and your work alone, and your response will be uploaded through plagiarism detection software like Turnitin. So importantly, it must be your own work. Okay, here's a problem that we're going to go through in more detail in the second video and help unpack what I've just explained in a more practical situation. I hope this has been of some benefit, and remember that this video itself might be a useful one to read or to review just before you start any problem solving task between grade 10 and 12. Thanks very much for listening.